there's always going to be one pair of coordinates at the point of intersection. So, for example, if you have a straight line, like, I'm just going to draw a straight line like this. Let's say here's your Cartesian plane. So let's say there's your Cartesian plane. That's X, that's Y, and you have another straight line over there. Okay, so here at the point of intersection, you have one X value and one Y value, right? If you have a straight line and a parabola, it's possible for there to be more than one point of intersection. So again, if we've got just a quick Cartesian plane, if I draw a parabola, say over there, and then I draw a straight line over here, I've got 2 points of intersection. Okay, so this is the more likely situation for you in grade 11. All right, so you would have to solve for 2 different X values and then 2 corresponding Y values as well. Okay, in the case of the first example that Mr. S has given us, this really isn't such a bad one to do. This would be more like a grade 10 problem because our hyperbola has not been shifted to the left or the right or up or down. It's still in the form y equals a over x. So he's given us y equals 6 over x. And he has also given us the straight line y equals x minus 1. Right, since both of them are equal to y, the easiest thing for you to do here is make them equal to each other. All right, so when you make them equal to each other, you can calculate the coordinates at this point of intersection and this point of intersection over there. All right, so in equating them to one another, you would end up with 6 over x being equal to x minus 1. Okay, so that's the easy part, is knowing that you have to equate them to each other. The hard part now is what comes next. Okay, so anybody in grade 11, do you know what the next step to solving for x is going to be? What would I have to do next in my equation? Any idea? Any ideas, grade 11s? What would we have to do next? Cool. Okay, so Morgan is saying multiply both sides by x, multiply both sides by x, multiply both sides by x. Absolutely. All right, guys, well done. So what we would need to do is we would need to multiply every single term in our equation by x. Exactly. Well done. So that means we would multiply here by x. We're going to times that by x. And we're going to times that by x as well. Okay, so to get rid of that denominator, that means that we're going to be left with 6 equals x squared minus x. What's our next step, matrix? I'm sorry, I'm also used to teaching the matrix. What's our next step, grade 11s? After we've multiplied through by x, what do we need to do now? Lovely, lovely, Awam. Standard form. So x squared minus x, bring the 6 over from the other side. Beautiful. Once we've got it into standard form, yes, lovely. That's it. Transpose the 6, standard form. Standard form, good. And after we've done that, we need to, my next step is going to be to, after I've got it into standard form, what do I want to do, grade 11s? Yes, by? I'm going to solve for x, lovely, by doing what? That's it. There we go. Perfect. I'm going to factorize. So because this is a trinomial, I'm going to have 2 brackets. x in the one, x in the other. And now I've got to think of two numbers. That's it. I solve by factorizing. I certainly do. I've got to think of two numbers. When I multiply them, it gives me -6. And their difference is -1. So that will be -3 plus 2, like so. Okay, so two solutions for x. Either x is equal to 3 or x is equal to -2. And when I go back, I can see that this makes sense. That looked like it was going to be 3, and that looked like it was going to be -2. And now I have to use one or of the other equations. So either I can use equation number 1, or I can use equation number 2. It really doesn't matter. I now need the y coordinate when x is 3 or when x is -2. So I think I'm going to use equation number 1. Really doesn't matter which one we use. So let's work out what y is. So y would be equal to 6 divided by 3. So that would give us 2. So y is 2. Or in this case over here, it would be 6 divided by -2. So therefore, y would be equal to -3. Okay, so my coordinates are 3 and 2, or -2 and -3, my points of intersection. How do we feel about that? Grade 11s, is that fairly straightforward? Are we happy? Any questions? Okay, cool. All right, lovely. All right, so now let's let you guys try one and we'll see how it goes. Although this one is a little bit more difficult. The one that I did with you was a bit easier. Okay. Let's just move this down. In fact, I think what I should do before I let you try that particular question, let's just do one of these with you, because it can become a little bit more difficult when you are working with a hyperbola that has been shifted to the left and to the right as well as up and down. So let me do an example with you and then we can come back and have a look at one. I'm going to choose example D. So I'm going to do this one with you. This example over here. Let's just make it a little bit bigger because I don't know how small that is on your screens. Okay, I'm going to do example D with you. So there's no diagram in D. We're just doing the maths behind it. Okay, so we know that n of x means y, and we know that p of x means y. They've just used functional notation. So n of x is our straight line, and p of x is our hyperbola. Okay, so now before we continue, I know we haven't sketched this hyperbola, but you guys have done functions already. First of all, I want you to tell me in which two quadrants is the hyperbola drawn? By looking at the equation of p of x, who can tell me in which quadrants the hyperbola is sketched? So you're looking at p of x. In which two quadrants would this hyperbola be sketched? Can anybody tell me that before we get started? Good, well done. In the second and the fourth quadrants. Good, lovely. Because the A value at the top is negative. Good stuff. Right. What is the equation? Good, well done. That's lovely, grade 11s. What is the equation of the horizontal asymptote of p of x? What is the equation of the horizontal asymptote of p of x? The equation of the horizontal asymptote of p of x. What is that? Good. Okay, Tsechofatso, you on fire here. Lovely, well done. Okay, so the equation of the horizontal asymptote, lovely guys, y equals -2. Beautiful. And the equation of the vertical asymptote, the equation of the vertical asymptote of P of x, please. The equation of the vertical asymptote. So mesh, Notolo, you're just missing a letter there. Zechofatso, good. Let's see who else here. Sitsaba, careful. Okay, so when they ask you for the equation of a vertical or a horizontal asymptote, you have to make sure that you write it with y and x. Okay, so just as you guys had told me, the equation of the horizontal asymptote, it is the line y equals -2. The equation of the vertical asymptote, it is the line x equals -3. So I know it says +3 here, but when it says +3 here, it means that the graph has been shifted 3 units to the left-hand side. That's the hard part. Okay, so the equation of the vertical asymptote, it is the line x equals -3. But don't stress about this. This will come as you do more and more functions. It'll become a little bit easier. Okay, so they want us to find the coordinates at the point of intersection. Okay, so again, the idea is that we need to equate them. All right, so at a point of intersection, at points of intersection, we would say that n of x equals p of x. Okay, so the first step, your first mark always here, grade 11s, will be to equate them. Okay, that will get you 1 mark, okay, for equating. When you are solving between a straight line and a hyperbola that has been shifted left or right as well as up or down, the easiest thing for you to do first is to transpose this value over here, whatever the horizontal asymptote is. Transpose that first. So take it over to the other side. Okay, so you're going to end up with -1 over x plus 3. And when you take this 2 over to the other side, you're going to add 2 to the left, so you're going to add 2 to the right. Okay, so that means that we're going to add 2 to this -5, so it's going to become -3. Okay, so that's the first thing that we've done, is we have transposed the -2. After you have done that, after you have dealt with a horizontal asymptote and moved it over to the other side, the next easiest thing for you to do is to cross multiply. Okay, now cross multiplication only happens when you are solving for x. There's no such thing as cross multiplication in any other place in maths. Often when you say to students, how do you multiply fractions? They say cross multiplication. That's not how you multiply fractions. When you solve equations, that's when you're allowed to cross multiply, because cross multiplying is the same as multiplying both sides by the denominator. That's what cross multiplying does. Okay, so essentially this -x -3 is over 1. So we're going to cross multiply by multiplying x plus 3 with -x -3, and we're going to cross multiply by multiplying this -1 at the top with that 1 down at the bottom. That's why we call it cross multiplication. Okay, so multiplying 1 with -1 is very easy. That gives us -1. And on the right-hand side, we're now multiplying -x -3 with x plus 3. So I'm just going to do this the long way, just so I don't lose anybody. I'm going to do FOIL. So first in is out is last. So when I multiply the firsts together, we would get minus x squared. Then we would end up with minus 3x. We'd end up with another minus 3x. And then we would end up with minus 9, like so. Okay, so after you have transposed the minus 2, you can cross multiply. And you can remove all your brackets. Okay, after this, what's the best thing for us to do? What should we do after this? So after I've transposed the minus 2, I've cross multiplied, I've removed my brackets, the same old story. Add like terms, absolutely, you're both correct. Transpose the minus 1, add like terms, yes. So all of this, the adding of the like terms, the transposing of the minus 1, oh, so good. Transpose everything so that the coefficient of x squared is not negative. Yes, lovely. So what we're trying to do here is we're trying to get it into standard form. Always, always, always. Okay, so we want to get to standard form. Okay, we have to have everything in standard form before we can use factorizing to solve. Okay, so what I'm going to do to make life easier for us is I'm going to move everything over to the left-hand side. So it's now going to be positive x squared. Minus 3x would be minus 6x. So it would be plus 6x on the left. And then I'm going to add 9 here. I'm going to add 9 here. So this is going to leave me with plus 8 equals 0. Is everybody happy that that's what I would have? Sorry, I haven't written that very nicely. Let me just move it up a little bit. So it would be x squared plus 6x plus 8. So I've moved everything over to the left-hand side, and I've collected my like terms, and I have got it into standard form. And now it's the same story as always. Okay, after you've removed brackets and got it into standard form, we've got to factorize. Okay, so this would give us x plus 4 times x plus 2. That's it, Mesh, quite right. We're always going to factorize. And 2 solutions for x. Okay, and that makes sense because our hyperbola is going to look something like that. It's sketched, that's very badly drawn by me. It's sketched in quadrants 2 and 4, and our straight line has got a negative gradient. Okay, so we know there have to be 2 points of intersection. So it makes sense that we end up with a quadratic. 2 solutions for x, either negative 4 or negative 2. Now we want to go back and work out what the corresponding y is. It's always easier to use the straight line. Okay, so we rather want to go and sub into n of x rather than p of x. Okay, so minus x minus 5 in order to get our y's. Lovely, well done, guys. Okay, so minus x minus 5. So working out what our y's are, minus x minus 5. So that gives us 4 minus 5, which gives us negative 1. So we've got negative 4, negative 1 as one point of intersection. And as far as the other one is concerned, y equals negative x minus 5. So that leaves us with 2 minus 5, which is negative 3. Okay, so we've got negative 2 and negative 3. Okay, cool. I get the same answers. Morgan, you got slightly different answers from me. Lebo, I haven't made any mistakes, have I? Can't see any mistakes.
No, I don't think so, Lee.
Okay, all right. So after standard form, we're going to factorize, solve for x, and solve for y. Okay, are there any questions, grade 11s? Any questions on what we've done? Are everybody okay? Thumbs up. Okay, so far so good. Beautiful. Okay, so now I'm going to give you guys something to try. Okay, all right, so let's go back to this guy over here. This is slightly easier than what we've done, but I'll give you one of those to practice as well. Let's do question 7. So you guys are going to do question 7. I don't know if Mr. S ever does this with you, but I always give my matrics a chance to work by themselves, and then we talk about answers afterwards. Does Mr. S do that with you too? Label, does he do that?
Yes, yes, he
Okay,
does, Lee.
all right, okay, cool. All right. So you guys are going to try this question. What do you normally do when it's ready for answers? Does he encourage the students to put them in the chat, or what do you do?
They usually put their answers in the chat as soon as they have them.
Okay, all right. So what Yolanda and I do is we get the students to DM us their answers, and then it doesn't put off anybody else that's still busy. Just in the chat, you just DM the teacher in the chat, but it doesn't matter. It's fine. Okay, guys, off you go. And then of course, if you need help, Lebo and I are here to assist you.
Give it a try, guys.
Okay, Tsegofatso, let's give you another one to try. Okay. Just move this up, Tsegofatso. Sorry, everybody, if you're still just busy with this one. Okay. If you are finished, okay, try this question that's popped into the screen on the left-hand side. So this y equals minus 6 over x plus 1 minus 2, and y equals minus 3x plus 2. You're going to try that. Okay. Michelle, same thing. That was very easy. Thank you, Morgan. Okay, how's everybody doing? With question 7. I know there's a couple of people that said that they were finished. Are we okay? Do we need any help? Are we stuck? Yes, Tsegofatso. You're welcome to unmute and speak if you'd like to.
Good afternoon, ma'am.
Good afternoon, Tsegofatso.
Ma'am, regarding question 7, I wanted to ask, before I factorize, if x has a coefficient, what do I do with that coefficient?
So just say that again. If x has
A coefficient, like maybe 2 or 3, because here the coefficient of x is 3. So I wanted to know what to do with that 3 when I want to factorize.
okay, are you talking about in question, are you talking about question 7 when you had to work out the coordinates at P and Q? Or are you talking about this other question that I've put down in the left-hand corner?
That other question that you put down.
The one in the left-hand corner?
Yes, ma'am.
Okay, all right. So if you have got a complex trinomial, you can either factorize it. If it doesn't want to factorize, you can use the quadratic formula.
Okay.
Okay, remember, you've always got the quadratic formula if factorizing becomes a pain in the backside. Okay. Do you remember what the quadratic formula is? Do you want me to write it up for you, Tegofatso?
No, ma'am, I can do it.
Okay, you got it. Okay, all right, that's fine. Okay, so in Bali, what we're going to do, what I've given a couple of other people to do was this question over here. So we did this one first. We did this question first. We're doing this one second. And don't worry about starting question 3 just yet. We'll see how that goes. I want to mark 1 and 2 with you. Okay, so let's just go back to question number 1. What we should have done here is equated 4 over x plus 2 with x minus 1. Again, the easiest thing for you to do, just have a look at your working now. The easiest thing for you to do would have been to take this minus 2 over to the other side so that you can cross multiply. This would leave you with 4 over x is equal to x minus 3, because we would have taken 2 away from both sides. This is over 1. So the best thing for us to do now is cross multiply. Okay, so we're going to multiply the 1 and the 4 together and the x with the x minus 3. So 4 times 1 leaves us with 4. And on the other side, we've got x times x minus 3. This gives us x squared minus 3x. Getting it into standard form, we would have ended up with x squared minus 3x minus 4. Factorizing now, we would have had x minus 4, x plus 1, 2 solutions for x. Either x is equal to 4 or x would be equal to -1. Okay, as far as y is concerned, we would have had 4 minus 1, which would have given us 3, or y equals minus 1, so y would have been equal to -2. Okay, how did that go? Well, let me give you a couple of minutes to mark it, and then you can tell me how you've managed. Okay, Tsegofatso's happy. How about everybody else? You sure, guys? No questions? Okay. All right. Good. Well done. Right. So what I'd like you to do, if there are no questions on number 1, I'd like you to try number 2. This is a 6 over here. This is a 6. Okay, try number 2. If you are finished with number 2, Tsegofatso, I think you were the only person who was finished with that one. You can try number 3, Tsegofatso, just as an extension question. Okay, so we're going to go on now. We're going to do number 2 or number 3. Okay, that's fine, Michelle. You can also try question number 3 as an extension question. Okay, Mesh, you can also try the extension question number 3. If you've done with number 2. Good, Nicolo. And Mesh, Unati. Well done. Okay, so some of you are done with 2. Good. That's lovely. Write question 3 down. I don't know if you know what to do with question 3, but what we could certainly do is leave that with you. I don't know if Mr. S ever gives you homework. I teach them the tricks at Watobe, so they they always get homework or something to try. Probably not what you guys want to be doing in your holidays, but I can certainly give you some hints and some pointers when it comes to question 3 if you don't know what to do. Okay, so a lot of you seem to be finished with question number 2. If it's all right, I'd like to go through that solution with you. What I'm going to do is I'm just going to move question 3 out the way here so that I can write over here next to question number 2. Okay. So in question 2, grade 11s again, when we are finding coordinates at the point of intersection, we've got to make these equal to one another. So we're going to take -6 over x plus 1 minus 2, and we are going to equate that to minus 3x plus 2. If you recall from earlier, the easiest thing for us to do now is to always take whatever value we've been given as the horizontal asymptote and transpose that value over to the other side so that we can cross multiply. So in our next step, the easiest thing for us is to keep the -6 over x plus 1, transpose the -2, so add 2 here, add 2 here. So we're going to end up with plus 4. After that, we can cross multiply. So the -6 is going to stay the same. And we're going to multiply -3x plus 4 with x plus 1, like so. I'm going to do FOIL, remove our brackets. This leaves us with -3x squared. Okay, so this is what you were talking about, Tsegofatso. And then here, this would be -3x, and then it would be plus 4x, and then it would be plus 4. Okay, so what I'm going to do is I'm going to transpose everything over to the other side, and we're going to end up with positive 3x squared. Minus 3x plus 4x would be positive x. So that would be minus x on this side. And then here, minus 4, so that would be minus 10 equals 0. Okay, I'm going to stop there. Did everybody get the same as me to this point? Has everybody got the same as me to this point? Are we talking the same language here? Yes, yes. Everybody happy so far? Okay. Not yet. Okay, Junior, that's fine. Hopefully you understand all the steps to lead us to this point. Now, this is going to factorize. It's not a nice one to factorize. You can use the quadratic formula if you want to. So if you'd like, I can show you both methods. It's up to you. What does make this a little bit easier to factorize is the fact that there is a 3 in front of the x squared. So 3 is a prime number. So it means that there aren't a lot of options. There's only 3 and 1. Okay, so if you do it this way to factorize, you can do it like this. So you've got 3x and 1x. And then as far as your factors of 10 are concerned, that would be 5 and 2 or 10 and 1. Always start with the numbers that are closer together. So 10 and 1 are further apart on the number line than 5 and 2. So go with 5 and 2 first. Okay, so what I'm going to do is I'm going to put the 2 over here and I'm going to put the 5 over there on purpose. Okay. This is so that when I cross multiply, so x with 5, I'm going to end up with 5x, and 3x with 2, I'm going to end up with 6x. Now, I want that because the difference between these two is -1. I can get -1 here. I can get -1x here if this one is minus and that one is plus. Okay, so this is if you wanted to factorize. This is a way of being able to work out what goes into the brackets. Is this a method with which you are familiar? This is usually what's taught in grade 9 and grade 10. And then the signs just go across into the brackets. So that bracket would be a plus and that bracket would be a minus. So we would end up with 3x plus 5, x minus 2, and then I can do a quick check using FOIL. So 3x squared minus 6x plus 5x gives me minus 1x, and positive 5 times negative 2 gives me negative 10. If factorizing does not float your boat, then you can use the quadratic formula. So the quadratic formula, if you recall, is negative b plus or minus b squared minus 4ac all over 2a. If you use the quadratic formula, you don't have to write it down like this, but you do have to show that you've subbed into it. So you must show the values of a, b, and c. So your other option here is to go x equals negative b. So that would be -1. Plus or minus. Don't leave out the plus or minus. Often a lot of students do that and it creates problems. Make sure you put b in brackets. That's -1 squared minus 4 times a is 3, and c in this case was -10. And that goes over 2 times 3. Okay, so we should find we get the same answers here. Either x is equal to -5/3 or x is equal to 2. If you pop what is on the screen as far as the quadratic formula into your calculator, I'm just sticking it into my calculator now as well, just to check. We are expecting the same answers. Yes. Okay, I'm getting the same answers. So either x is equal to -5/3 or x was equal to 2. So a lot of the time, they give you a mark for factors. They give you a mark on this line. You've got to make sure that you've got the equal 0 there if you use factors. Okay, if you leave off that equal 0, you're going to be penalized. And in matric, there's often an accuracy on that line. Okay, or your alternative is to sub into the quadratic formula. Okay. Are you guys getting the same answers as far as the x's are concerned? Okay, so either your factors or the quadratic formula. Once we've done that, y equals -3x plus 2. I'm just going to write that on the side over here because we need to work out what y is. Okay, so y would be equal to -3 times or into 5/3 plus 2. So that means that y would be equal to -3 times -5 would be 15. 15 divided by 3 is 5, and 5 plus 2, that would be 7. Or y would be equal to -3 times 2 plus 2. So y would be equal to -6 plus 2, which would be -4. Did you guys get the same answers? Okay, so either x is -5/3 or it's 2, and y is 7 or it is -4. Are we happy with that? Good. Good. Any questions? Any questions, grade 11s? Sure? Everybody happy? No questions? Okay. All right. Well, if nobody's got any questions, then I'm going to leave this. Where was it? Oh, I think I popped it up onto the other side. Not other side, but somewhere over there. Oh, yes. So, yes, Junior, you got a question? You can unmute and speak, Junior, please.
I have a question. So,
Sure.
I lost. Y is equal to y is equal to 4 minus 1. How did you get 2? Because in this equation they say x minus 3x plus 4.
Yes. So
So
I took everything over to the left-hand side. So
I
you can
see here.
see.
So here I see negative 3 and open bracket negative 5 to 3 plus 2. How? Because
I'm not
I
following
don't
you. I'm not following you, Junior. Where was our difference in our answers?
know. I got in y I got 2 and the other side I got negative 4.
Oh, so over here you got 2. Where I got 7, you got 2. Is that what you're saying? Here you got 2.
I got 2.
Oh, okay. All right. So let's just double check that I haven't made a mistake. All right. So if y is equal to negative 3x plus 2, and we know that x is minus 5 over 3, then we've got negative 3 into negative 5 over 3 plus 2. So when you multiply fractions, you're multiplying numerator with numerator and denominator with denominator. So negative 3 times negative 5 is positive 15. And 1 times 3 is 3. And then we've got plus 2. So 15 divided by 3 is 5. And 5 plus 2 is where the 7 comes from.
I see now.
Okay. Are you happy
Yeah.
with that, Junior?
Thanks.